If you've ever wondered why you slip around in this mushy, gross weather that we have sometimes when the snow falls and turns to mush, our wise guy Matt Sellin is here to explain, and we're talking about anti-lock brakes.
We're going to talk about anti-lock brakes, and I want to mention something really quick first. When you're in your car and you're taking a corner, so you're, this is sort of like driving in a circle, except it's only part of a circle.
Right.
For the same size circle, the force required to keep you going in that circle, the force that friction has to provide from the road, is proportional to the square of how fast you're going.
Okay.
So if you go twice as fast, you use 4 times as much force, which is why you can slide off the road.
Sure.
But that means that slowing down a bit helps a lot. So always go slow when it's slippery.
Okay.
Now, here's the important thing to understand anti-lock brakes.
We've got toys.
I do.
Besides
okay, hang on the wheel.
Remote control car.
That's the remote control car. First thing we're going to do is we're going to pull on this block of wood, and I want this tells you how this little meter is measuring what the tension is in the string and how much force is required.
Oh.
So notice that to get the thing going, it takes more force. Okay, the little needle went up to 8 or 10 newtons of force just to get the thing moving, but once it's moving, the force is smaller.
Okay.
What that means is the frictional force between an object and whatever it's riding on is biggest when the object isn't moving, when
Right.
it's static, okay? Once it starts to skid, the frictional force gets smaller. That's because it sort of sticks when it isn't moving. Once it's moving, it slips, and so the friction is smaller.
Okay.
The other thing to note is that a wheel that rolls on the ground is static. It doesn't move with respect to the ground. It's not skidding, right? So if you look at this piece of tape, as it passes the ground, it's just like this piece of wood. It's not moving relative to the table.
Okay.
So when a wheel rolls like this, it can have a larger frictional force on it from the road than if you slam on the brakes and it skids, the frictional force is going to be smaller.
Okay.
Just because sliding friction is always smaller than static friction is called when the things are not sliding.
Sure.
Okay, so that's the principle of anti-lock brakes.
Okay.
What you want to do when you're in your car is you never want to push on the brakes so hard that the wheels lock up.
Okay.
Because not only when they lock up do you have less friction between the wheel and the road, which means you can't stop or accelerate as fast, it also means that if the wheels lock up, you can't steer, you can't do anything. It's
right.
really bad. So what happens is there's a little computer in your car. And if you've been driving, if you go out this very morning and you're driving to work and you slam on the brakes and you have anti-lock brakes, you hear this little this funny little sound, right?
I've heard that.
What's happening, right? What's happening there is that there's a computer in your car. As soon as your wheel starts to lock up, the computer releases the brakes. Even though your foot is still pushing on the pedal, the computer releases them so the wheel starts to roll again.
Okay.
And then the computer applies the brakes kind of gently until the wheel starts to slip, then releases them again. And so that little tick, tick, tick sound that you hear from your car is the computer not letting the wheels lock up. It's doing its best to keep them rolling instead of sliding, because that way you have a bigger frictional force, and that way you can stop instead of going to have more control. Exactly right. And the same thing also for accelerating. If you have some cars have this traction business where if you step on the gas too hard, it kind of eases back, and it doesn't allow you to spin the wheels. So that's how you stay safe.
The science behind it all. Matt, thanks for being here today with all the toys to demonstrate what goes on inside our cars as we're out there driving. If you have any questions for our wise guy, you can email us at themorningshow@wcia.com. Jen?